Hey, good morning, everybody. All right, so I got in here about 45, 50 minutes ago from work. I'm going to go ahead and take just a couple of minutes and finish this up. All that was left was putting the feedbacks in, so we got that taken care of. Um, Overall, really pleased with the way this thing tuned out, as far as a whole. So, as you guys probably remember from earlier this week in the videos, um, we went ahead and pulled everything apart and redid it. Good morning, whoever we got in there this morning. So, we pulled out all the stuff as far as for our input, got that taken care of, replaced the relay. Need to wipe these off and send these back with you. Like I said, they are still functioning if you choose to use them. But we pulled out the light to knock off of it. The 1446 DEIs that were in there, so those are no longer in there anymore. Set that off to the side for the moment. All right, so yeah, I mean, complete and total rebuild basically. Geez, oh Pete's, all that, right down to the little 10 gauge wire. That's all been replaced. Now we are running just a single 8 gauge. Again, I knew you were going to be just running radio drive into this, so it'll be enough, especially whenever I get to the current draw. You'll see that it's actually enough for pretty close to what you're doing. So I think you're going to be fine with that. But anyways, we pulled all the other stuff out. We went ahead and replaced your transistor strips. Went ahead and installed the new DEIs, HG 2879s. So those are in there. We replaced your output capacitors. We pulled the silver dips out. We went ahead and put the metal clad micas in there. Just a little bit beefier build for it. The only thing that we really couldn't do to this, and a lot of it was room constraints due to the distance. Even if we would have left the original relay in there, just not quite enough room to go ahead and go up to like 1.5-inch transformer. So we utilized your output transformers as well as your input because they were in still really good condition. Same thing with our capacitors here from collector to ground. Beautiful there. We replaced all your 10 ohms since we were already at that stage. Like I said, what's another quarter? You do have a blocking diode now. In theory, what this is in here for is if for some reason you were to ever hook it up backwards or something of that nature, it should go ahead and allow you to blow the fuse before you wind up with any kind of damage to the main components in here. So, I like putting a fairly beefy one in there myself. So that's in there. We've got the 3-pole relay in order to go ahead and switch the biasing on and off at the same duration. So that was one of the other things. Let's see here. All right, so it's just a notification. It's finally told me that I'm live. But anyhow, now the only thing that's left that we're going to go back through and check, but we'll do that right at the end. Reason why is because I will probably have to make a slight change to it, which is going to be your pass-through. So that's not a big deal. Figured I'd save that and take care of that there at the very end of this. So for what we're doing right now, it's not a critical portion of it. Like I said, so we've got your biasing all ran and put in up here. Everything turned out beautiful on that. We'll also show you here as far as on the KC901 with the Spectrum Analyzer, show you what it looks like. Speaking of which, we'll go ahead and shut that off, and we'll key up the radio and just show you with radio drive only to start with. So another thing, we also went ahead and beefed up your input power wires going from our main B plus rail to the transformers. So we got rid of the 16 gauge and we put in a heavy 14 gauge off of each one. So that way we don't have almost any kind of lag as far as power consumption. So that's taken care of. Your relay or your capacitors for your sideband delay, that actually works pretty good right where it's at. We didn't have to make any changes or alterations to that. It's actually enough to take care of you as far as for your sideband needs. But otherwise, like I said, we're good to go on it. I've still got to make you up a bill. I'll do that later this afternoon when I get up. But anyhow, we'll kind of go from there. Probably have to reset everything because everything's been on for a little bit. So turn that back on. All right, so we've got this set right now for, should be up for a 50 megahertz band across the Spectrum Analyzer. So we're gonna go out as far as 50 megahertz on this. That's what we're gonna do. Principal signal for what we're doing today. We're going to be on channel 15, which is 27135. There is our principal signal. Hello, audio. So nice clean signal going into the amplifier. And we are running our President Richard. So hello, audio. Alrighty. So let's go ahead and we're just going to start right here with the Spectrum Analyzer. And we'll work all the way up to the actual meters themselves as far as for your output. So amplifiers on, and we are running at 14.5 volts. Hello, audio. So nice clean signal across there. We've got one small harmonic that's showing up down here around 70 dBm. There again, it's going to be so low that you're not going to really ever see or have any kind of inkling that there's even any harmonics, provided that your radio is nice and clean to start with. So, all right. And I'm going to also show you here. So we're going to go up here to the other one. And let's go out here, Spand. Let's take this one because this only goes out about 5 megahertz. Okay. We'll get rid of that. So I don't remember why. I think it's just so that this actually gives you the marker of the end of the frequency span. So that's, from what I've seen, that's actually pretty normal for what I've looked up on this Spectrum Analyzer. So again, there's our principal signal. Hello, audio. So, nice and clean. Alrighty, so let's also see what kind of amperage draw we've got here going on. Let's set the cover on this. Get one of the top screws here, and we'll put that in there quick. All right. So the current draw. Hello, audio. So about 53 amps. This is a dual final radio, so like I said, we've got roughly about 55 to 60 watts PEP going into it. Hello, audio. Let's do this. Way to make life a little easier to see. There is 100 watt slug. All right, so we get 100 watt slug. Hello, audio. Audio. So about 55 on the PEP. Over here to the RMS as far as with what I'm running into it right now. Hello, audio. So about 21 bird. So that's how much drive we're actually putting into it. All right, so we'll go through the band here real quick. Oops, and I do apologize. I thought I had the camera up. So let me get back in here. I've got the camera setting on in a different location, so it's a little harder to see. All right, so let me pull that back out and we'll put the 100 watt back in there. That way you can see. All right. So 100 watt slug in 1X position right now for pass through. Hello, audio. So we got about 55 on the PEP. Again on the RMS. Hello, audio. Audio. So total of about 21 RMS we're actually putting into this. All right. All right, so we got our 5 watt slug and one, it's going to be 1X because there's direct feed. So 5 watt slug going back to the radio for input reflect, 5 watt slug going back from the 5,000 watt bird dummy load, 1,000 watt slug in 1X position for PEP, and 1,000 watts for RMS. All right, so let's see. Turn this back on. Carry up a little bit. Hello, audio. Audio. So we got about 575 on the PEP. Audio. And about 375 on the RMS. Some pretty good numbers. Go over here and let's look at the output reflect. Hello, audio. So we got about 2 watts reflect, or 0.2 of a watt reflect coming back from the dummy load. Over here on the radio side. Hello, audio. So about 1.5 tenths. So just a little over 1/10 of a watt, which is really, really good. All right, so let's turn that back off. We'll look and see what our pass through is, and then we'll hook up the analyzer and actually confirm everything on that and finalize it. So, hello, audio. So just a little over 1/10 of a watt reflect. So let's go ahead and pull that out. here. Just easier to use a small little handheld dummy load for this test than it is to sit there and leave it hooked up to the 5,000 watt bird dummy load. This is just a small one from Telewave. If you guys aren't familiar with them, they are an incredibly great company to get test equipment and test gear from. Okay. Let's see here, go to function, mode. And SWR. Takes me a minute sometimes. Now it's below the 1.6. S11 format. Impedance has got a really good line here. SWR. Trying to remember how to bring the zero back up. It's been a few days since I've done that. That's the different phasing. Return loss. 0. So 23.87 on the dB. It's actually really good for where we're at. And we'll look at this on the Smith chart. So we've got about 54 is what we're looking at. Ohms of resistance. Theoretical goal is 50 ohms. So Q factor, we've got a very nice high Q factor. All right. Yeah, some of this, guys, there is so much on this. It's just like, let's see. Okay, there's our center frequency. All right, and sometimes it's easier because I'm still having to get the book out at times for this, guys. Of course, I haven't been using that for 4 or 5 years like some of the other people. All right. Plus, after doing 13 hours of regular work and then coming in here for another hour, sometimes your brain kind of gets fried. All right, so let's go here and turn this thing on. Set up all parameters. All right, so we got an SWR of 1.1. Let's see if we can't drop that down just a hair more. .05 at 50 ohms. Okay, so let's go ahead and get this thing put in. Disconnect your power. And we'll get that trimmed down. Yeah, I'm also going to have to get me another roll of solder put out tomorrow. My large stuff's kind of empty at the moment. since this goes on the secondary relay in here in order to go ahead and complete the entire circuit. Sometimes it gets a little busy in there to get to that. All right. So we got 1.0 on the pass-through with a 50 point. We're going to call it 50.3 since it's fluctuating between 0.3 and 0.4. So we're at the ideal mark across the band with that we're after. All right, so we are good to go on that big guy. So we already got your new badging on there. Pass-through's done. Let's see what it looks like on the meter. I hook this all back up. All right. Roll back in. All right, so pass through. Hello, hello, hello. Audio. Audio. Less than 1/10 of a watt. So that's definitely where we want to be at on that too. All righty. Looks pretty good there, I think. All righty. Let's do one more quick test here. As soon as this warms up. Hey, good morning. Yes, I am still live, 3. Give me 1 minute and I'll, if you'd like, you can either give me a text or give me a call. All right, so let's turn this back on real quick. Plug it back in. Hello, audio. 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 All right. So as things start heating back up, we're going to be able to see what our hot spots are, which typically you're going to see the resistors. The biasing, they're going to start getting warmed up. Transistors, they're running nice and cold, although they do still generate quite a bit of heat. Nothing back here on our transformers. You might even be able to see my finger here in the small screen. Look back here. Hello, hello, hello. Audio. Audio. Hello. So across the board, even back here by the relay. Audio. So everything's running just nice and cool. Nice and even all the way across. All righty. Well, that is where we're at on this big guy. Like I said, I'll get these cleaned up and I'll wrap those in a piece of paper towel, send those back with this. Like I said, later on this afternoon when I get up, I'll sit down and figure up a bill and we'll try to get together and get this shipped back to you. All right, guys. Take care. I appreciate it. Have a great evening.